Hi students, we are going to explain perpendicular axis theorem now. For that, we are going to consider a plane laminar body like this. So this is a plane sheet. This is called as a plane laminar body. Its a shape, I have taken rectangular shape, but it may be of any shape, which is whose thickness is very less comparing to the length and breadth. So such a sheet is called plane laminar body, and we are going to prove the perpendicular axis theorem with the help of the plane laminar body. Okay students, now you take this is a rectangular lamina. This is a rectangular lamina. Now the longer side, that is called the length, and the shorter side is called the breadth. I am going to consider three different axes of rotation for this laminar body. Can you all see the sticks which are pasted on the sheet? Okay. So you can see that by the right side I have written x-axis. Is it visible students? X-axis. So this longer axis is called the x-axis. And this one, the vertical axis, is called the y-axis. Okay. Now perpendicular to these x and y, another axis I have taken. Can you all see this movement of this third axis which is perpendicular to both x and y? That is called the z-axis. You know very well that when the axis of rotation of a body changes, it will definitely change its moment of inertia. So, if x-axis is taken as the axis of rotation, the body can rotate with the longer axis like this. So, its moment of inertia can be taken as ix, and if you take the y-axis as the axis of rotation, so this one, the body can rotate like this, the body can rotate like this, so that the moment of inertia about the y-axis is taken as iy. Also, now the body can rotate about the z-axis like this. So, the body can rotate about the z-axis. So, its moment of inertia is taken as iz. There is a relationship between the moment of inertia of this lamina about the three mutually perpendicular axes. This is only called as the perpendicular axis theorem. Okay students, well, now you look at the board. What is Ix in this diagram? So this is a plane laminar body. I have chosen the x-axis, and this is the y-axis. Perpendicular to both x and y is the z-axis. So this is the z-axis. Now these three axes are mutually perpendicular to each other. So what is Ix in this picture? Ix is the moment of inertia of the plane lamina about the x-axis. And what is Iy? It is the moment of inertia of the plane lamina about the y-axis. And Iz is the moment of inertia of the plane lamina about the z-axis. Then according to the perpendicular axis theorem, Iz is equal to Ix plus Iy, because Iz only is perpendicular to both x as well as the y-axis. Therefore, Iz is taken on the left hand side. Now the other two terms are on the right hand side. We are going to prove now. So for the proof, first I will consider a particle P, which is having or considered to be a point mass. Okay students, so its mass is a small m, that is a point mass. So you will see the coordinates of P, the x coordinate as well as the y coordinate. You see that P is located at a distance r, okay, at a distance r from O. So OP, the length OP is equal to r, and the x and y coordinates of P are x, y. Okay students, therefore r square must be equal to x square plus y square. This is the equation 1. Okay students, it is like a Pythagoras theorem, is it not? So P is located at a distance r from the z-axis. Therefore r square must be equal to x square plus y square. Okay. Now I will consider only the moment of inertia of the point mass. Moment of inertia of the point mass. Okay. About the z-axis. About the z-axis I will take. That is equal to its mass into distance square. Therefore, the moment of inertia of the entire lamina, okay, of the laminar body, about the z-axis. So we are going to add all the terms for all the particles. So this is denoted as Iz, that is equal to sigma m into r square, that is equal to sigma m into, instead of r square shall we substitute equation 1, therefore r square I am substituting, this is equal to x square plus y square. So Iz is now equal to sigma m x square plus sigma m y square. Okay, what are x and y in this picture? Let us see now. So x is the perpendicular distance of the particle from the y-axis. Am I right? You see here, x is clearly the distance of the particle p from which axis? Y-axis. Therefore, this term must be equal to sigma mx square must be equal to the moment of inertia of the lamina about the y-axis. Similarly, what is y here you see? Very clearly, y is the perpendicular distance of the particle p from the x-axis. Therefore, this term sigma my square must be equal to the moment of inertia of the lamina about the x-axis. So, now we can rewrite this as Iz is equal to Ix plus Iy. So, we have proved the perpendicular axis theorem with the help of a plane laminar body, and we must write this in words.